Hello, in this video I'm going to solve the following problem for you. Evaluate the following integral. Integral of sine inverse of x squared. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, this is the answer that you are going to get. X times sine inverse x squared plus 2 times square root of 1 minus x squared times sine inverse x minus 2x plus a constant c. Okay, so let us do it here on the board. I have done some trial and error. So one way to do it is actually to get rid of sine inverse and then try to do integration by parts. The way that I use it, so I will introduce sine inverse. I introduce the capital X to be sine inverse of x. Okay, so then immediately I would realize that x is sine of capital X. I also need to write dx, so I would write dx is equal to the derivative of this is cosine capital X d capital X. And then I give this a name I, so I is equal to integral. Instead of sine inverse I put capital X, so it becomes capital X squared, and instead of dx I put cosine x dx. Okay, and hopefully you see that this is an integral can be calculated using integration by parts, but because we have the second power of x here, we have to do it 2 times. Okay, so the formula for integration by parts is integral u dv is equal to uv minus integral v du. So I give the role of u to this, and I give the role of dv to this. Okay, so if u is equal to x squared, I need du on the right side, so du becomes the derivative of x squared to capital X and d capital X. And then dv is equal to cosine capital X d capital X. And then of course v is just a primitive function of cosine, which is sine. One primitive function is enough. Yes, so I didn't plug them here. So integral of u dv is equal to u times v. This is my u, this is my v, so this becomes this. Yes, and then minus integral v du. This is v, this is du, there is a constant 2, I pull it out here, and then it becomes x sine x dx. Okay, and then of course you know that I have to do integration by parts once more. So this was successful because I reduced the degree of this polynomial 1 unit. It was x squared before, I have x, of course instead of a cosine I have sine. Okay, so I will do the same trick here. This time, if you don't mind, let me call this integral j, and I give the role of u to this, and I give the role of dv to this. Okay, so u is x, so du is the same as dx. Okay, and then dv is sine x dx. So this means that v is a primitive function of sine, which is minus cosine x. So the integral j that I am looking for is uv, which becomes minus x cosine x, yes, and then minus integral of v du. So this is my v, this is my du, but there is a minus sign here, I pull it out, so it becomes plus, it becomes cosine x dx. And of course, I go one step more, so I copy and paste the first term, integral of cosine is simply sine. Okay, I don't consider the constant c, I combine all the constants together at the very end and I call them c. Okay, so this is my j, I put it back there to be able to find my I. So finally, I is equal to this expression, x squared sine x, and then minus 2 times what I got here. So it becomes plus 2x cosine x minus 2 sine x. Okay, because I is finished here, so that would be a good idea if I put my constant c at the very end. Of course, this is not an acceptable answer because I have to write everything back in terms of my original variable, which was little x. Okay, so that is also simple because I see that sine x is just simply x. Okay, and then capital X is sine inverse of x. So the only thing that I have to calculate is cosine capital X. And that's also extremely simple, yes? Because we know that sine to the power of 2x plus cosine to the power of 2x should be 1. But sine capital X, if you see on the board, it is little x. So this becomes x squared plus cosine is 1. And then I move this to the other side. And then take the square root. So I take this 2, put the square root here, and of course I have to put plus or minus. Okay? But the minus sign is not acceptable because when I took capital X to be sine inverse, it means capital X is in the range of sine inverse of x. And we know that the range of sine inverse of x, which in this case I called it x, it should be between minus pi over 2 up to pi over 2. Yes? So this means that this x is somewhere in the fourth or in the first quadrant, and in both of them cosine is positive. So there is no matter of confusion here because cosine capital X has to be positive, so it means that the negative sign is not acceptable. And if you put everything back here, you will exactly get the answer proposed by the book. So I is equal to capital X is sine inverse of x, sine x is little x. Okay, so this becomes simply x sine inverse of x to power 2, and then I have plus 2 capital X, which is plus 2 sine inverse of x. So if you don't mind, let me write sine inverse of x here. And then I have to multiply it by cosine of x, which I got it to be this. So this becomes 2 times this. And then minus 2 sine x, which is again little x. And then I have a constant c at the end. So this is the answer to this integral. Okay? So you see here I use integration by parts 2 times. But if you don't mind, let me also tell you this so you can do it in one go. So for example, if I want to calculate this, especially if I have a polynomial here, what you do, we took this u, you just put it here, and then from the second function, you'd find a primitive function. So if I ask you what the primitive function of cosine is, it becomes simply sine x. Okay? And then every time you go forward, you differentiate this function and integrate this function and change the sign. So you alternatively go from positive sign to negative sign. So for example, when I want to start the second term, I started with a positive one. I put a negative sign here. Remember, I differentiate it, so it becomes 2x. But I integrate this, which becomes negative cosine x. Okay? And then I go to the next step. I change the sign. I differentiate this part, which becomes 2. I integrate this part, which becomes minus sine x. Oh, sorry, minus sine capital X. Yes? Again, I go forward. I change the sign to negative. I differentiate this, it becomes 0. I integrate this, it becomes cosine x. Of course, there is no point to continue this process because this remains always 0 if I differentiate. So it was a faster way to do it. Instead, so that's also integration by parts in 2 steps, but that's more efficient to do it in that way, especially if you have a polynomial here, because you know that if you have a polynomial, differentiating it over and over again finally gives rise to 0. Okay, so then what happens? So this becomes x squared sine x. This becomes positive 2 x cosine x. This becomes a negative 2 sine x, and the rest of the terms are 0. So this is hopefully what we got there. So you see, that is exactly this answer. I'm just telling you that this is the same thing. I have done integration by parts 2 times, but this is a very efficient way to think about, especially if you have a polynomial here. So what you choose as you just put it here directly. You integrate the next function and put it here. And the process will continue like this. You change the sign alternatively, okay? Every time you differentiate this and integrate this, okay? So that is a faster way of doing that. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.